Hi, everyone. Today we're going to look at some review questions. I sent out some review questions on your D2L site a few days ago. Let's take a look at these. Let's actually work through some of these. I have the work done on them. And so let's take a look. Okay, so I'm going to share my screen. So just hang on a sec. There we go. These are the actual questions we took a look at. Let's move up here. Whoops. Move up to the top. Get all queued up. So the first thing we see is we have a question that deals with functions. There are going to be lots of questions that deal with functions in this test. Okay, so we have a set of ordered pairs. Remember, the x's are the domain values and the y's are the range values. To be a function, every x has to have only one y pairing. In other words, if an x is paired with two different y's, it's not a function. So let's take a look. Here's 2. 2 is paired up with 3. No other place in the set is 2 paired up with a different y. The next ordered pair has an 8 in it. Nowhere else in this set is 8 paired up with anything but -7, as far as y is concerned. 2/3, the next x. No place else in this set is an x equal 2/3 paired up with something other than 3. 4, same idea. No place in this set is 4 paired up with any other y but -9. And then -1 for x, no place in the set is that paired up with anything but -6. So it's a function. You're going to have several function evaluations along the way. This says t of x equals -6 plus 7. So when we see something like t of -3, what that means is we plug -3 in every place there's an x here and follow the order of operations. So that means we have -6 times -3 because we're replacing the x with -3. That gives us -18 plus 7 gives us, or +18 rather, plus 7 gives us 25. T of 2, same idea. We plug 2 in for x and then follow the order of operations. So -6 times 2 gives us -12, plus 7 gives us -5. And then T of 1/6, we plug 1/6 in for x and follow the order of operations. Fortunately here, the -6 and 2, this 6 right here is in the denominator. The -6 out front is in the numerator, so the 6's cancel. Since this is negative, it leaves us with -1. -1 plus 7 gives us 6. 3, there are lots of ways you can do 3. I'll tell you how to do both, or 3 different ways eventually, but we're focused on 2 ways at the moment. So the 2 ways you could do it is you could plug 2 in for x, for f of 2, and 4 in for y, or I'm sorry, for x, for f of 4, and then add them together. So evaluate each one separately and add together. Okay, that's what it looks like. Okay, so that's one way. The other way is you could just do it on the side. F of 2 is 11, f of 4 is 33, add up and get 44. You can do the same thing with f of 2 minus f of 4. You can evaluate each in one long expression, distributing the minus when you're done. Or you could just remember that f of 2 is 11, f of 4 is 33, 11 minus 33 gives us -22. And then C says find f of x plus 2. So what's f of x plus 2? Well, f of x plus 2, if I take and remember what f of 2 is 11. So f of x, that just means write down f of x. So that's the 2x squared minus x plus 5. And then we're going to add f of 2, which is 11, to that. So that gives us 2x squared minus x plus 5 plus 11, which gives us 2x squared minus x. When I add the 5 and 11 together, that becomes 16. I will send later a sheet for you that does this one on the side. Off this, I didn't have room to do this one, the graphic approach to that. But we will look at the substitution and elimination methods here. Okay, for substitution, what does substitution method mean? It means that you need to actually isolate one of the variables, either x or y, and substitute it into the other equation to solve for the variable that's left over. So in this case, when I look at x minus y equals 2, essentially I can solve for x by adding y to both sides. So I'm going to do that. Okay, so adding y to both sides, I get x equals 2 plus y. I'm going to take this 2 plus y, put it in parentheses, and substitute it in for x in the second equation. So that gives us 3 times the quantity 2 plus y equals 1. Distributing the 3, 6 plus 3y plus y equals 1. Combining the y's, 4y plus 6 equals 1. Subtracting 6 and dividing by 4 gives us y equals minus 5/4. Now that's part of the solution. The other part is when we find the x. To find x, we go back to x equal 2 plus y, plug in minus 5/4. So x will equal 2 plus or minus 5/4, which is 3/4. Since all these problems, these 3 problems are the same system of equations, we should get the same solution. Let's take a look at the elimination method. The elimination method means that we eliminate one of the variables by matching up the coefficients from an x or y with opposite signs, adding together, and they cancel out. So in this case, when I look at this just by inspection, I have a minus 2x and a 3x. The x's will not cancel if I add them together. I have a 2y and a y. The y's will not cancel when I add them together. So that means I'm going to have to multiply one or both equations by something so that I can get a match up with opposite signs so that they cancel out. So when I look at this, I could do the x's if I wanted to. But I have minus 2x and a 3x. So I think about common multiples. Okay? That said, that's kind of like a lowest common denominator. Okay, so what would the lowest common denominator between 2 and 3 be? It'd be 6. So I'd want a 6 and a minus 6 in front of the x's. So to do that, I'd have to multiply this first equation by 3 to get minus 6x. Then I'd have to multiply the second equation by 2 to get 6x. Or I look at the y's. I have that choice. I could do either one. So I have a 2y and a y. So if I had a minus 2y here, 2y and minus 2y will cancel out. And that means I don't have to multiply one equation by minus 2. So I'm going to do that. So I'm eliminating the y by multiplying the second equation by minus 2. This gives us minus 6x, and don't forget to multiply the entire equation. Minus 2y equals minus 2. Add the two equations, we get minus 8x equals minus 6. Divide both sides by minus 8, we get 6 over 8, or 3/4. Same value we got in the other one for x. Then I take the 3/4, I substitute it in for x in one of these two original equations. I chose the first one, just for the fun of it. I could have chose the second one as well. I put 3/4 in. Okay, I can do a little cancellation here with the 2 and the 4. And 2 goes into 4 twice, so that gives us a minus 3/2. Minus 3/2 plus 2y equals minus 4. I'm going to multiply everything by 2. Multiplying everything by 2 gets rid of the denominator of 2, and it might make it a little bit easier. I add 3 to both sides and divide by 4, and we get minus 5/4 for y, which again is exactly what we got. Now, when I'm doing this test, there's going to be exponent problems. Okay, and the exponent problems, what I suggest you do is you have examples out in front of you, maybe these 3 examples, along with other examples you may have done in homework. And then also, I would have the exponent rules in front of me. Since our tests are not timed, you have all that time in the world to find examples that are similar. Okay, so in this case, we're multiplying minus 3x y to the third with 2x to the fourth y to the fifth. Since there's no exponent outside of the parentheses for either case, we can drop the parentheses and multiply the two together by grouping the minus 3 and the 2. That gives us minus 6. Grouping the x's, x times x to the fourth. Remember, when we have two things we're multiplying the same base with, we add them. That gives us x to the fifth. And then y to the third times y to the fifth. That gives us y to the eighth. For part B, it's a little bit messier, okay, because we have this exponent on the outside. That 3 on the outside of the set of parentheses here means I have to move this 3 in and apply it to everything inside of that set of parentheses. If there's an exponent already inside of the parentheses, I have to multiply the two exponents together. Okay, so there's no exponent with the 4 other than 1. There's a 4 to the first there. So when I move the 3 and I just write it as 4 to the third. But for x squared, there's the exponent inside the parentheses. So when I move this 3 in, I'm going to take x squared times 3. Same thing with the y. I'm going to take y to the 7 times 3 because there's an exponent of 7 already in the parentheses. So that gives us then 4 to the third is 64. So 2 times 4 times x to the 6th from the 2 times 3 and y to the 21st from the 3 times 7. So I just multiply the 2 and the 64 together and get 128. So 128x to the 6th, y to the 21st is our final answer. Let's scroll down a bit. Move C up more to the center of our page. Whoops, that's a little too far. Okay, this one we have a fraction with some negative exponents. Remember, negative exponents mean if it's in the denominator and it's negative, you move it up to the numerator and make it positive. If it's a numerator and it's negative, you move it down to the denominator and make it positive. Okay, so the first thing I'm going to do is I'm going to divide out the 2 and the 16. That gives us 1/8. I'm going to use the exponent rule where I'm taking the same base and dividing. So I write the top exponent minus the bottom exponent. So it's going to be x to the minus third minus, since we're subtracting, the bottom exponent, -8. I do the same thing with the y. I have a y to the first and a y to the third. So I write y to the 1 minus 3 power, and then z to the minus third is just z to the minus third. Doesn't cancel out with anything in the bottom. So when I actually subtract the minus 3 and the minus 1/8, or minus 8 rather, I get 5. But when I subtract the 1 minus 3, I get -2 and z to the minus third. So the 1/8, well, there's a 1 in front of the x, so I don't have to worry about it. If you wrote it, that's okay. But I have an x to the 5th that stays where it's at. It has a positive exponent. Y has a negative exponent of 9 to the minus 2. So it has to be moved down to the numerator, or I'm sorry, the denominator as y squared. Z to the minus third is a negative exponent as well. So it too has to be moved down to the denominator as z to the third. Any questions? Oh, good spelling for foil there, Tim. Let's change that to actually the correct spelling. There we go. Okay, so when we have 2 terms times 2 terms, we distribute twice. So I'll distribute the 3s with the 2s and the 5. So 3s times 2s and 3s times 5. And then I'm going to distribute the minus 2 with the 2s and the 5. So minus 2 times 2s and minus 2 times 5. When we simplify and combine like terms, we get 6s plus 11s minus 10. And then as far as subtracting and adding 2 things in this format of f minus g of x, remember f minus g of 2. We did earlier. It's basically anytime you have this, okay, scenario, you're going to take f of x, f plus g of x. That's the same thing as f of x plus g of x. Remember what we did up above. We just added the 2 functions together. Same thing with f of minus g of x. Okay, remember what we did above. We just subtracted the 2 functions. Now when you have the subtraction, you're going to have to combine the like terms, but you're going to have to distribute before you combine the like terms. When you just have addition, you just combine the like terms. So let's do subtraction first. So we have f minus g of x. It's the same thing as f of x minus g of x. So I write down f of x, and I write down g of x in parentheses. There's nothing to distribute for this 3x plus 4, so I drop the parentheses. For the minus 5x minus 7, I distribute the negative. Minus minus becomes positive in both cases, 5x plus 7. Combine the like terms, we get 8x plus 11. And then for f plus g of x, it's the same thing as f of x plus g of x. So here's f of x, here's g of x. We start with both in parentheses just in case we have to distribute something, but we don't. In either case, there's nothing out here to distribute, and it's a positive, so there's nothing there to distribute. So we can drop the parentheses and combine our like terms. Well, obviously you don't have any questions. I'm so used to asking that. That was a silly question of mine. Okay, so factoring is an important skill in math, especially in Math 119. So let's take a look at the different types of factoring we've seen. So one of the things we saw was factoring out a greatest common factor. That's the number that divides with every number that's included in the polynomial. It's the largest. So when we have numbers, we just look for the number that would divide evenly with each. So we have 8, 24, and 4, and that number would be 4. As far as the variables are concerned, we select out the smallest power. That's common if it's a common variable for all terms. So in this case, the x has an x squared here, an x to the 5th here, and an x cubed there. So x squared is the smallest power, so we factor that out. Y is present in all 3 terms, a y to the 1st, y to the 2nd, and a y to the 4th, so we factor out a y. The lowest power for y is y to the 1st. And then it's just a matter of figuring out what I have to multiply the 4x squared y by to get 8x squared y. What I would have to multiply the 4x, so this should be actually, should be 6, not 12. There we go. Multiply the 4 with to get 24x to the 5th, y to the 2nd. And multiply the 4x squared y to get 4x to the 3rd, y to the 3rd, or 4th. Okay. There's also going to be some AC method problems. Now, some of you might be used to AC method. Some of you might have done the umbrella approach in high school. Some of you may have done trial and error. I don't care which way you do it. I'm going to do the AC method. Okay, so what the AC method does, you multiply the number in front of x squared with the last term. So that's 1 times 6, or 6. You look at the middle term, which is minus 5. You need 2 numbers that multiply to be 6, add up to minus 5. Minus 3 times minus 2, or minus 2 times 3 gives us 6. And minus 3 plus a minus 2 give us minus 5. Are those numbers always easy to find? No, they're not. Sometimes they're very difficult. Okay? It might take a little bit of guess and check, if you will, even with this method. So then what we do is we write this middle term of 5xy minus 5xy with a minus 3xy and a minus 2xy. These two right here, if I add them together, will add up to minus 5xy. And I factor by grouping. So I group the first 2 and the second 2. The first 2, the common factor there is x. The last 2, the common factor, if a third number is minus, we typically factor the minus out along with anything else. What it does is it changes everything inside the set of parentheses. So if this started out minus, this first term will be positive. If this first term started out positive, the second term rather positive, it will be negative when I factor the negative out. So that factor a minus 2 and a y because they have y in common, and that gives us x minus 3y and x minus 3y in both cases. These two have to match. If they do, we factor it out front, keeping it in parentheses, and then putting in parentheses what's left over, in this case the x, and the minus 2y. Another factoring by grouping problem is C. So again, I group the first 2 and the last 2. The first 2 I can factor out a 2x squared, leaving us with 2x minus 3. The second 2, the third number in this case is negative, so I'll factor negative out and anything else. So I can factor a 3 out of 6 and 9, so I factor minus 3 out. Now remember, that changes the sign of everything in the parentheses. So that gives us a positive 2x and a minus 3, because minus 3 times minus 3, we have to end up with positive 9. That's how it changes. And then the 2x minus 3 is common in both places, so we factor that out in parentheses, put it out front, and put in parentheses the other 2 numbers that we factored out a couple of minutes ago. And that completes the factorization of that. D is a trinomial. Remember, trinomials are 3 terms. Typically, the largest exponent is 2. That we factor in this AC method way. So A is 6, and C is minus 6 here at the end. So I multiply the 2 together and get minus 36. Need to add up to minus 5. So I'm going to choose minus 9 and 4, because minus 9 times 4 is 36. And minus 9 plus 4 is minus 5. Again, those aren't always that quick. Okay? So don't get discouraged if it takes you a little bit longer. That's okay. So then I rewrite 6x squared minus 9x plus 4x minus 6, rewriting as minus 5x. as minus 9x and 4x. It's like we have there. The first set of parentheses, I can factor a 3x out. That gives us 2x minus 3. Since the third number here is positive, I don't have to worry about factoring the negative out. So we just factor out the 2, giving us 2x minus 3. The 2x minus 3 is common in both slots. So now we factor it out, keeping it in parentheses, and putting whatever we factored out a couple of minutes ago, in this case the 3x and the 2, in their own set of parentheses. Question E is a difference of squares. That's one of those special forms. Since the square root of 121 is 11, and the x is squared, and the square root of 144 is 12, and the y is squared, and we have subtraction between them, it's the difference of squares. So what did I square to get the 121? I squared 11, and then I have to square x to get x squared. What did I square to get the 144? I squared 12, and y to get y squared. So I put 11x and 12y in both sets of parentheses. One has a negative, one has a positive. That's the difference of squares. It's just a formula that you have to remember. Doesn't matter if the minus and plus are switched around. It does matter, though, that you have 11x and minus 12y and 11x and plus 12y. You couldn't have the 11x and the 12y switched around. F is a sum of cubes. There's sum and difference of cubes. Again, these are formulas. You figure out what you had to cube to get y cubed. Well, it's y. And then what do we cube to get 216? Remember, that's third power. You'd have to third power of 6. Okay? And so the form for this, okay, y plus what I cubed, 6, and then y squared minus what I cubed times y plus what I cubed in the second slot squared. That's always the form. If it was the difference, if there was a subtraction here, then it'd be minus here and plus inside this trinomial part. That's the only difference. The plus gets flip-flopped. The plus goes here. The minus goes here if it's a difference of cubes. Then the other thing I wanted to talk about was solving by factoring. Solving by factoring is one of the methods we solve equations with. The name tells it all. So basically we want one side to equal 0, and then we want to factor completely. So this first problem, this is the messiest of them all, is 9x cubed plus 21x squared plus 10 equals 0. I always look to see if I can factor greatest common factor out first. In this case, we can. We can factor an x out. So we do. So that gives us inside the parentheses 9x squared plus 21x plus 10. Now for this 9x squared plus 21x plus 10, I'm going to use the AC method. Using the AC method, I need two numbers that multiply 9 times 10 would be 90 and add up to 21. And so 15 times 6, again, these aren't always going to be that quick, but 15 times 6 is 90, and 15 plus 6 is 21. So I rewrite this 21x as 15x and 6x. I'm just working right inside the parentheses here. The x I factored out just is dropping down, following right along. Okay, so I can factor a 3x out of the 9x squared plus 15x. I can factor a 2 out of the 6x plus 10. That gives us 3x plus 5 in both of these slots. We'll factor out the 3x plus 5, leaving us with 3x plus 2. So that came from that set of parentheses right here with the 9x squared plus 21x plus 10. The x is still just coming along for the ride. Okay, now I set each factor equal to 0. Why? Because I'm multiplying three things. I'm multiplying an x, a 3x plus 5, and a 3x plus 2. If multiplication equals 0, at least one of those numbers has to be 0. So x could be 0. There's nothing to solve there. X is already isolated. The 3x plus 5 could be 0. So we could subtract 5 and divide by 3 and get minus 5/3. The 3x plus 2 could be 0. So we subtract 2 and divide by 3 and get minus 2/3. So any of those three numbers can be a solution here. How do you check? You could plug these into the original equation and see if it came out to be 0. For B, 4x squared is a square. I have to square 2 and x. And 49 is a square. I have to square 7. So the square root of 4x squared is 2x, so I put it here and here. The square root of 49 is 7, so I have a plus in front of one of the 7s and a minus in front of the other. I set each factor equal to 0, so the 2x plus 7 equals 0. We would subtract 7 and divide by 2 and get minus 7 over 2. And then 2x minus 7 equals 0. We would add 7 and divide by 2 and get 7 over 2. So either one of those or both of those are solutions to that equation. Now our last equation is 3x squared plus 2x minus 5 equals 0. And I'm going to use the AC method again for this because it's a square with a trinomial, 3 terms. So 3 times minus 5 is minus 15. So I need 2 numbers that multiply to be minus 15 and add up to 2. And those 2 numbers would be minus 3 and 5. Minus 3 times 5 is 15, and minus 3 plus 5 is 2. So I factor by grouping, and we get 3x plus 5 as one set of parentheses, and x minus 1 as the other. I set 3x plus 5 equals 0. This gives us minus 5/3, and x minus 1 equals 0 gives us 1. Okay, so that's your review sheet. Let me now go back here and let me share another screen with you. Here we go. You're going to receive this today. It deals with the work of that system of equations. And then also, I threw in a synthetic division problem. Let's talk about synthetic division for a minute. Okay, so when it says divide x plus 2 with x squared plus 7x plus 3. So the first thing we do is we only look at this plus 2 part. And with synthetic division, after you multiply, you have to subtract. So I like to eliminate errors here. So if this is a plus, I'll make it a minus when I do the synthetic division. Okay? If it was a minus, I'd make it a plus here. Okay? And then for this part right here, inside this division box, I put the number in front of x squared, the number in front of 7 and 3. Or the number in front of x rather than 3. So 1, 7, and 3. Those are called coefficients and constants. This would be a constant because it has no variable. Okay? I drop this first number straight down, this leading term straight down. I take this number and multiply it with it. So minus 2 times 1 gives us minus 2. 7 plus minus 2 gives us 5. I take this minus 2, multiply it with the answer I got here. 5 times minus 2 gives us minus 10. Put it here, add it with this number, and that gives us minus 7. There's nothing else left, so that's the remainder. So when we divide an x squared with an x, we end up with an x. Okay? X squared over x is x. So this 1, if I rewrite it out, is 1x. This number, since it's an x, the next number would have no x, it'd be a constant, so that'd be 5. And then this minus 7 is the remainder, so we write minus 7 over what we divided with. So you'll receive that later today. Hopefully this helps. Now don't forget, the test window now I believe is open. So take your test. If you have any questions, make sure to tell me. Have a good day.